Here we're going to take a closer look at the way we calculated the number of decays over one of the millennia. If you recall, after 5 millennia, the rate at which the sample was decaying was 1.2 times 10 to the 11th decays per millennium. At the 10 millennium mark, the number of decays was down to 0.9 times 10 to the 11th decays per millennium. Okay, these distances in this direction are measured along this axis, the vertical or the y-axis if you wish, and they represent the number of decays times 10 to the 11th, the number of decays per millennium. Of course, here on the clock time axis, measuring t in millennia, we go from 5 to 10 millennia, and we see that we have a trapezoid. The trapezoid has altitudes 1.2 times 10 to the 11th decays per millennium. 10 to the 11th seems to be off the edge. And 0.9 times 10 to the 11th decays per millennium. And the trapezoid has a width of 5 millennia, from 5 to 10 millennia. Now what do we do when we calculate the number of decays over a 5 millennium period? We take the average rate at which the sample is decaying times the time interval. In this case, the average rate between the 1.2 and the 0.9 times 10 to the 11th decays per millennium is 1.05 times 10 to the 11th decays per millennium. Once more with an apology for significant figures. So we have 1.05 times 10 to the 11th per millennium multiplied by the 5 millennia. If we multiply this out, we end up with 5.25 times 10 to the 11th decays. Now if we look back at the trapezoid, we see a rate going from 1.2 down to 0.9. That rate is changing, and we could find the rate at which it's changing by taking the slope here, but we're not interested in that right now. We might be interested at some point. But we see that the average rate, if the rate goes down at a constant rate, the average rate is going to be 1.05 times 10 to the 11th, of course, decays per millennium. Now the actual curve, as you can see, if this dotted line dips down a little bit below the straight line approximation. So we don't have an exact figure when we call this the average rate, but it's a pretty good approximation to the average rate as long as the interval is fairly short, as long as we don't have a big long time interval. To get the number of decays, we take the average rate and we multiply it by the time interval. The time interval is 5 millennia. That's nothing but the width of this trapezoid. So that in the process of calculating the number of decays, we've multiplied the average altitude of this trapezoid, which represents the average rate, by the width of the trapezoid. Therefore, we've obtained the area of the trapezoid.